Always do it on my own, so I gotta get through it. And the only thing
Welcome guys to my channel Programming Adru. Without wasting any time, let's start with our topic, that is time complexity. So let's first take a example. Okay, like for a minute assume that you are very game lover and you like GTA 5. Okay, so you thought that I will call my friend and ask him where I can download the GTA 5, and you can download it in your internet. And after seeing the size of the game, you thought that should I go to my friend house and bring the game physically, and after returning home I will just start playing the game, right? So you have two choices, whether you download it in online or visit your friend house physically. At first step, when you are downloading your game online, the size of the game depends on the time it will take to download in your computer, right? If it's 80 GB, it will take maybe 3 hours. If it's 90 GB, it may take 5 hours. If it's 120 GB, then it will take more hours, right? But when you are visiting your house, in your friend house, the game size doesn't matter, right? Whether it's 120 GB, whether it's 200 GB, the size doesn't matter. The time because the size of the game doesn't hamper your time, right? Your visiting time, whether you take a auto to visit the house or by walking, the time will be same, right? Whether is the size of the game is 80 GB, 90 GB or 200, 300, doesn't matter. So here you can see that the size of a game, when you are downloading it online, the size of the game is directly proportional to the time. The size, the time, right? If the size is 80 GB, it will take 5 hours, or if it 90 GB, it will take 6 hours. The size of the game depends, but here you can see the time not depend on the size of the game. Here the time is constant, okay, with respect to size, right? Size of the game. So here you can see the time is constant, but we calculate that in our, right, 5 hours or not. But when we are calculating our time in program, we don't calculate the time in seconds or minutes. We do in BigO, a special thing only for programming. Okay, so because why we don't compare, right? If your laptop is 20,000 laptop, then and your friend's laptop is 50,000, they both have the huge difference, right? His RAM may be 16 GB, your RAM may be 8 GB or 4 GB, right? And his processor may be high, latest. You're not, right? That time his program will run faster because of the faster processor and RAM, but your program will not in your computer. And because of that, it making a barrier, we are using a special thing where it will not require the latest RAM or the processor to run the program, the calculating the runtime of the program. We need BigO. So first we will see what is the constant value of the BigO. When the time is constant, doesn't depend on the size, like we saw that the size of a game. Here also there, the time is constant. So BigO of 1 is a constant. When you see BigO of 1, that means constant. So you can see the random numbers 1, 2, 5, 6, 4, 7, 8 till 8. So here we will add the last 2 digits of the list, the number from the list, like 1 and 8. So like 1 plus 8 equals to 9, right? The 7, there are 7 numbers and you take your steps with 1. If you take from 1 to 10, 9, 10, just add some numbers like 9, 10, 11, 12, and the time, then the steps will be same, right? You're just adding 1, and if the last number is 12, you will just 1 plus 12 equals 13. Wherever you increase the number, the steps will be 1, right? Always. That time the steps doesn't proportional to the number you are adding to the list, right? The steps will be. Here the time is constant, it doesn't depend on the n, right? That's why we go of 1. Here we go of n. So here is the not constant, it depends on the n, right? For example, like we take a random number 2, 4, 7, 8, 10, 11. Now we will find 11 from the list. Okay, so first we took 11 with compared 11 with 2. You can see it not 2 is not 11, right? The step is 1, n is equal to 1. So we compare 4 with 11. You can see 4 is also not 11. So now steps 2 and n is 2. Now the 7. Again 7 is not 11. So steps 3 and n equals 3. Now steps 8. Now steps 4, n equals to 4. Now 10. So now 11 is compared with 11. Now is 11, okay. So steps is 5 and n equals to 5. So here you can see as the n is increasing, the steps are also increasing, right? So here the steps is directly proportional to the n, right? That's why it is the big O of n. Steps depends on the n, and that's why big O of n. So now we'll see that n into m. Time complexity. For example, we take a 3D array of 3 into 3, and here you can see some loops, for loops. When we are taking a 3D array, how we will take. For example, you can see for when I is 1, j will run only once, right? Because j is equal to 1, less than equal to 1. So 1, when I is equal to 1, j will 1, and again it will go back to I. When I will become 2, the j will run from 1 and 2. Like for when I is 3, it will run from 1 to 3. So here you can see the n to the power square, right? So if you take I is as n and j as m, so n into m. Now we will see the big O of log n. So let's take a binary search example. Okay, so if you see that 1, 13, 14, 20, a random number, okay, in a sequence order, right? 13, 14, 20, 20, 20, 34. Here I need to find 14. Okay, first we'll divide in half. We got 1, 13, 14 and 20. Now 34, 7, 27, we don't need it. We know that 14 is, we divide it in that 14. Okay, now we'll again divide into half. Now we'll divide 14 and 20. We got 14 and 20. Now again we'll divide that. Now we got the number 14. Here you can see how the log of n complexity is there. We are getting dividing until we got the number, the required key number. Thank you guys. See you on the next topic.
Always do it on my own, so I gotta get through it. And the only thing I know